Well, I welcome all the students and the participants who are attending this live lecture. Today in this live lecture, we shall discuss the concept regarding the Wronskian and linear independence of the homogeneous or non-homogeneous differential equation of variable coefficients. Say this. So, this is the next bit of our unit, that is, this is the unit number 2nd, and in that unit number 2nd we have, in the last lecture we have seen that the solution of the homogeneous equation. How to find out the solution of the homogeneous equation having a variable coefficients. Also we have seen the 3 different theorems regarding this, and also we have seen one example which is used to convert the homogeneous differential equation in terms of d1. d1 is equals to dy by dz. In this form we have solved some examples also. Now we shall discuss today we shall discuss the Wronskian and linear independence. Now students, our examination will be started from I think 5 April. So before that we have to complete all the syllabus, so we can arrange the extra lectures. That means we can complete our total syllabus, because again there are 2 units are remaining, but both the units are very small, so we can manage all these units in the 10 days. Okay. Now we shall discuss the Wronskian of linear dependence and independence. Actually, I shall revise this concept. The linear equation with variable coefficient, that is linear differential equation with variable coefficient. A differential equation of the form a0 a0 of x y raised to n plus a1 of x y raised to n minus 1. Actually this is not the index, it is the derivative. So that can be written as y0 of x dny by dx raised to n, a0 of x a1 of x dny dn minus 1y by dx raised to n plus a2x a2 of x dn minus 2y divided by dx raised to n plus dot 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 an of x y, which is equals to bx. Here a0, a1, a2 dot 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 an are the complex valued function on some real interval I. If b of x is equals to 0, then this is the form of a homogeneous differential equation with variable coefficients, and if b of x is not equals to 0, then this is the non-homogeneous differential equation with the variable coefficients. Okay. Manisha Mali, Saddam, okay, Jadhav, Maske, Tejashwani, okay. Now we shall start the Wronskian and linear dependence. We know that the definition of the Wronskian, you know that if y1, y2, y3, y4 dot 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 yn be the solution of a given differential equation, then its Wronskian is defined as Wronskian of phi1, phi2, phi3 dot 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 phi n of x. Wronskian of phi1, phi2, phi3, phi1 of x, which is given by or which is equals to the determinant of phi1, phi2 dot 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 phi n, phi1 dash, phi2 dash dot 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 phi n dash dot dot dot. In this way, phi1 n minus 1, phi2 its derivative n minus 1, phi3 its derivative n minus 1 dot 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 phi n its derivative n minus 1. The value of this determinant is called as, the value of this determinant is defined as the Wronskian. We have seen, already we have seen this concept in the homogeneous differential equation of order n having a constant coefficients. Okay. That is the same case here which we have to use. Okay. Now, okay. ठीक आहे. प्रतीक्षा आहे का? प्रतीक्षा आहे का ऑनलाईन? प्रतीक्षा क्लास नाही करत. ठीक आहे. तिची अटेंडन्स तिच्याकडनं काढून दुसऱ्याकडे द्यावं लागेल. प्रतीक्षा लेक्चरच नाही करत. ठीक आहे. माधुरी पवार, जे विद्यार्थी आता ऑनलाईन आहेत, मी जेव्हा एखादा क्वेश्चन करेल ज्यावेळेस मी प्रेझेंटी घेईल त्यावेळेस माधुरी पवार तू काय कर, स्क्रीनशॉट घेऊन माझ्याकडे पाठव. ठीक आहे. ओके. नाउ वी शॅल डिस्कस द नेक्स्ट theorem, that is theorem number 6. Up till we have studied the five theorems regarding the linear differential equation with variable coefficients. So we shall discuss this next theorem. If phi 1, phi 2, phi 3 ... phi n are solution of L of y is equals to 0, that means the homogeneous differential equation on an interval I, they are linearly independent if and only if they are Wronskian, that is the Wronskian of phi 1, phi 2, phi 3 ... phi n of x, which is not equals to 0 for all x in I. See this, same theorem we have proved in the unit number 1, in the chapter number 1, linear homogeneous differential equation of order n having constant coefficients. Same theorem, same condition here we have to use. Here also the proof of the theorem is the same as like a previous theorem. यहाँ पे देखो बहुत सारे theorem, इस chapter 2 के बहुत सारे theorem chapter 1 के theorem जैसे ही है. थोड़ा बहुत कहाँ तो difference है, बाकी all theorems are nearly about same, but all these theorems are regarding with the variable coefficients, and previously all the theorems are regarding with the constant coefficient. Okay. Now, if and only if, actually we have given the statement of this theorem is in the form of, see there, in the form of if and only if. देखो यहाँ पे अगर थ्योरम if and only if होता है, सबसे पहले देखो आपको याद रखना है, कभी भी कहाँ पर भी मैथमेटिक्स में अगर थ्योरम if and only if के स्टेटमेंट वाले होते हैं तो उसे हम दो पार्ट में प्रूव करना होता है. सपोज ये if and only if b, we can write this as, suppose if and only if b, a is one condition, b is another condition, a is one condition and b is another conditions, then the statement regarding if and only if, then how to prove the theorems, all the theorems of mathematics which are bounded by if and only if, then we have to prove in the particular way. First of all, you have to consider this condition. This is a condition, this is a conclusion. First of all, consider the condition and prove the conclusion. This is a case first, part first. And in second part or in the converse condition, we have to prove the result. This is a condition, we can say it is a result. We have to consider the result and prove the condition. इसी तरह से हमें प्रूव करना है. देखो, first of all we have to see this. What is the statement of this theorem? Phi 1, phi 2, phi 3 ... phi n are solution of L of y which is equals to 0, which are linearly independent. Then we have to first prove that its Wronskian is equals to 0, is not equals to 0. And second part, if Wronskian is not equals to 0, then we have to prove phi 1, phi 2, phi 3 are लिनियरली इंडिपेंडंट. ओके. हां, काय म्हणतं सद्दाम? थांब, सद्दाम मी नंतर चर्चा करतो. हां, ओके. हाँ सद्दाम, वेट, मैं बाद में डिस्कस करता हूँ व्हाट इज योर प्रॉब्लम. ओके, सी दिस. Now suppose that, now start the proof. Now suppose that Wronskian of phi 1 comma phi 2 phi 3 dot 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 phi n of x, which is not equals to 0. That means we have considered Wronskian is not equals to 0, then we have to prove phi 1, phi 2, phi 3 are linearly independent for all x in I. There are constants C1, C2, C3 dot 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 Cn such that, you know that, such that C1 phi 1 plus C2 phi 2 plus C3 phi 3 dot 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 Cn phi n is equals to 0. We have seen many times of this condition, but by the differentiating C1 phi 1 dash plus C2 phi 2 dash plus C3 phi 3 dash dot 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 Cn phi n dash, which is equals to 0. Okay, now if we continuing the differentiation process, then we get up to the n minus 1th differentiation. Right side to 0 hai, constant C1 C2 is the constant, so we are differentiating only the function phi 1 phi 2 phi 3 in higher order form. So we get C1 phi 1 raised to n minus 1 means n minus 1 the derivative, C2 phi 2 raised to n minus 1 dot 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 Cn phi n raised to n minus 1, which is equals to 0 for all x in I. Suppose x is fixed in I, then equation 1 and 2 are linearly homogeneous equations satisfied by C1, C2, C3 dot 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 Cn. Suppose that we consider x is fixed, x is a particular point, so it becomes suppose constant. Then we get the equation 1 and 2 means total these equations, system of these equations becomes a homogeneous equation, and which is satisfied the unknown constants C1, C2, C3 dot dot Cn, because we have considered x is a fixed. If x is a fixed, then phi dash, these are the fixed values. So the determinant of a coefficient of the homogeneous equation, which is the given by the Wronskian phi 1, phi 1, phi 2, phi 3, phi n dot 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 phi n of x, which is not 0 according to the condition of the homogeneous equation. Hence there is only one solution of this system, that is C1 equals to C2 equals to C3 dot 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 equals to Cn equals to 0, and this proves that phi 1 comma phi 2 comma phi 3 dot 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 phi n are linearly independent on I. This is the first part which we have proved. In the first part we have considered Wronskian of phi 1 comma phi 2 phi 3 dot 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 of phi n of x, which is not equals to 0, and we have proved the solution phi 1, phi 2, phi 3 are linearly independent. Now in the second part we have considered, suppose that phi 1 comma phi 2 comma phi 3 dot 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 phi n are linearly independent. अभी कॉन्वर्सली हमें क्या करना है, phi 1, phi 2, phi 3 dot 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 phi n are linearly independent कंसिडर करते हैं हम. तो प्रूव क्या करना पड़ेगा रे स्टूडेंट्स, अभी सभी ने यहाँ पे चार्ट बॉक्स में लिखना है. अभी हमने सेकंड पार्ट में इसको हम कॉन्वर्सली भी बोलेंगे. तो सेकंड पार्ट में हमने क्या कंसिडर किया है, phi 1 कॉमा phi 2 कॉमा phi 3 डॉट 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 phi n are linearly independent on I. Then we have to prove. What we have to prove? See this according to the theorem. Wronskian of x, which is not equals to 0. First part मध्ये काय केलं, Wronskian of x is not equals to 0 we have considered, and we have proved phi 1, phi 2, phi 3 are linearly independent. अभी सेकंड पार्ट में कॉन्वर्सली में हमें अपोजिट करना है, तो बताना है स्टूडेंट्स इसका रिजल्ट क्या करना है. सपोज दैट phi1, phi2 डॉट 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 phi n आर लिनियरली इंडिपेंडंट ऑन I, देन वी हॅव टू प्रूव्ह. हा, काय प्रूव्ह करावं लागेल रे? चला रे, चॅट बॉक्स मध्ये सांगा. अनुराधागिरी, राईट डाऊन. नितीन पवार, सद्दाम, रवीना पाटील, गणेश काळे, माधुरी पवार, इंद्रायणी पुजारी. Now see this, phi1, phi2, phi3 are supposed to be linearly independent, then we have to prove that Wronskian is not equals to 0. Yes, okay, Rutuja Bhosle, we have to prove Wronskian is not equals to 0. Now this second part can be proved by the method of contradiction. What is that contradictions here? Suppose phi1, phi2, phi3 are dot 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 phi n are the linearly independent, then also Wronskian is not equals to 0. Suppose there is a point x0 in I such that Wronskian of x0 is equals to 0. We have to prove x0 is equals to 0. Actually we have to prove Wronskian is not equals to 0, but this can be proved by the method of a contradiction. So we have to suppose the contradiction that Wronskian phi1, phi2 dot 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 phi n of x naught equals to 0. Now this implies that the system of n linearly independent solutions, again for the point x naught in interval I, they are also having the solution. Suppose this is x naught be a point in the given interval, suppose I. That point is x naught. Then we have to show that it has the system of n linearly independent regarding to the x naught, and that are c1 phi1 of x. माधुरी पवार ज्यांचे आन्सर्स आलेले आहेत त्यांची स्क्रीनशॉट काढून घे आणि नंतर लेक्चर संपल्यानंतर पाठव. जेवढे विद्यार्थी आहेत अटेंड करतात त्यांचे. This implies that the system of n linearly independent equations, so we can write c1 phi1 of x naught plus c2 phi2 of x naught plus dot 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 cn phi n of x naught is equals to 0. Now this is the second, by differentiating first order c1 phi1 dash of x naught plus c2 phi2 dash of x naught dot 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 cn phi n dash of x naught is equals to 0. These are the n linearly independent solution, because we have considered, we have supposed here, suppose that phi1, phi2, phi3 are linearly independent solutions. So it has also linearly independent solution at the point x naught. So we get the system of linearly independent equations, and that has a solution. Definitely it has a solution, c1 comma c2 dot dot cn, where not all constants c1 comma c2 comma c3 dot 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 cn are zeros. Let c1 c2 dot dot cn be such solution, and consider the function psi is equals to c1 phi1 plus c2 phi2 plus cn phi n dot dot cn phi n. Now L of psi is equals to 0, and from equation 3 we have psi of x naught equals to 0, psi dash of x naught is equals to 0, dot 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 psi n minus 1 of x naught is equals to 0. But from the theorem it follows that psi of x is equals to 0 for all x in I. This implies that c1 phi1 of x plus c2 phi2 of x dot 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 cn phi n of x, which is equals to 0 for all x in I according to the theorem. But this is a contradiction fact that phi1 comma phi2 dot 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 phi n are linearly independent on I, because we have supposed phi1 phi2 phi3 are linearly independent, and this is the contradicts that phi1 phi2 phi3 are the linearly independent on I. This implies that, thus the supposition that there was a point x naught in I such that Wronskian of phi1 comma phi2 dot 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 phi n of x naught which is equals to 0 must be wrong, which we have supposed here, which must be wrong, because this gives a conclusion that C1 phi 1 plus C2 phi 2 dot dot of Cn phi n, which is equals to 0. This is the contradiction to the linearly independent of phi 1, phi 2, phi 3. So we get the result that Wronskian, which is supposed to be 0, is wrong, and hence we say that the Wronskian of phi 1 comma phi 2 dot 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 phi n of x, which is not equals to 0 for all x in I, and hence proved. अशा पद्धतीने हा थेरम आपला प्रूव्ह होतो. ठीक आहे. नेक्स्ट वी शॅल डिस्कस द थेरम नंबर 7. थेरम जास्त आहेत. आता तुमचा MCQ टाइप क्वेश्चन पेपर असल्यामुळे थेरमच्या स्टेटमेंट, नोट, रिमार्क हे चांगल्या पद्धतीने तुम्ही करा, परंतु हा तुमच्याकडे हे सिलेबस असणं गरजेचं आहे. हे टिपिकल आहे, म्हणून हे सर्वच्या सर्व नोट्स चांगल्या पद्धतीने लिहून घ्या. ओके. लेट नाउ नेक्स्ट थेरम, लेट phi 1 comma phi 2 dot 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 phi n be n linearly independent solutions of L of y is equals to 0 on an interval I. If phi is any solution of L of y is equals to 0 on I, it can be in the form, that solution can be written in the form phi is equals to C1 phi 1 plus C2 phi 2 plus C3 phi 3 dot 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 Cn phi n, where C1, C2, C3 dot 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 Cn are the constants. Thus, any set of n linearly independent solutions of L of y is equals to 0 on I is basis for the solution of L of y, which is equals to 0 on I. We have to prove this. The set of linearly independent solution of L of y equals to 0 on I is the basis for the solution of L of y is equals to 0 on I. You know the definition of the basis, which we have studied in the previous lecture, in the unit number 1st. So we have to prove these independent solutions having the basis. Okay. So now suppose let x naught be a point in I. X naught be a point in I. Suppose that phi of x naught is equals to alpha 1. This is the condition. Suppose phi dash of x naught is equals to alpha 2. It is the initial condition. Dot 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 phi raised to n minus 1 of x naught, which is equals to alpha n. Now we have to show that there exist unique constants C1, C2, C3 dot dot Cn such that psi is equals to C1 phi 1 plus C2 phi 2 plus dot 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 Cn phi n. Equation number 1. That means this will be the solution of L of y, which is equals to 0. Is a solution of L of y which is equals to 0. You know that you have solved lot of problems regarding this. याच्यावरून तुम्ही खूप प्रॉब्लेम सॉल्व केलेले आहेत. Now also psi satisfies the equation because psi is a solution. You know that psi is a solution of L of y is equals to 0. Though psi satisfies the differential equation having the condition psi of x naught is equals to alpha 1, psi dash of x naught is equals to alpha 2, because we have considered psi is a solution. Dot 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 psi raised to n minus 1 of x naught, which is equals to alpha n. But by the uniqueness theorem, we have seen theorem number 3, that is uniqueness theorem. That means every homogeneous differential equation, linear differential equation, it may be variable coefficient or it may be constant coefficient, it has a unique solution. In the chapter 1st, we have also proved uniqueness theorem. In the chapter 2nd, we have also proved uniqueness theorem for linear differential equation of order n. According to the uniqueness theorem, we can write both these solutions, that is a phi and psi, are one and same, or we can say equal. So we can write phi is equals to C1 phi 1 plus C2 phi 2 plus C3 phi 3 dot 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 Cn phi n. Okay. Here the initial condition for psi are equivalent to follow the equations for C1, C2, C3 dot 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 Cn. That means C1 phi 1 of x naught plus C2 phi 2 of x naught dot 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 Cn phi n of x naught is equals to supposed to be alpha 1. C1 phi 1 dash of x naught plus C2 phi 2 dash of x naught plus dot 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 Cn phi n dash of x naught is equals to alpha 2. In this way, continuation this C1 phi 1 raised to n minus 1 of x naught plus C2 phi raised to n minus 1 of x naught dot dot Cn phi raised to n minus 1 of x naught is equals to alpha n. This is the set of linearly independent solutions for C1 comma C2 dot 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 Cn. The determinant of the coefficient, we all know the determinant of the coefficient is given by the Wronskian of phi 1 comma phi 2 dot 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 phi n of x naught, which is not equals to 0. अगर linearly independent solution है तो ये 0 नहीं होता है. So since phi 1, phi 2, phi 3 are the linearly independent, because why we can say that the coefficient of the Wronskian which is not equals to 0, because phi 1, phi 2, phi 3 are the linearly independent solutions. Okay. So so we can write, therefore there is a unique solution. Then there is definitely, we say that unique solution C1 comma C2 dot 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 Cn of the equation number, suppose of the equation number, see this, 1 minute, 1, 2, 3, of the equation number 3, and hence proved. So we can say that this is the unique solution of the equation number, see this, okay, no problem. So we can write this and hence proved. Okay. Now next we shall discuss the another theorem. हे सर्व theorems आहेत, थोडे व्यवस्थित चांगल्या पद्धतीने लिहून घ्या, एक दोन वेळा लिहून काढा. या कन्सेप्ट परत 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 त्याच आलेल्या आहेत. All these terms are, all these theorems conditions are repeating in the unit number second, in the chapter second. We have already seen the theorems based on this in the chapter number first. Also this is a theorem which we have also studied in the chapter number first. See this, you can see the chapter first. This theorem is also we have studied, but in the chapter first we have given the condition linear differential equation with constant coefficient. Here is the difference is that the linear differential equation with the variable coefficients. Only the difference is that. Okay. Now see here, theorem number 8, let phi 1 comma phi 2 dot 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 phi n be solution of L of y is equals to 0 on an interval I, and let x naught be any point in I. Then we have to prove, then prove that Wronskian phi 1, phi 2, phi 3, phi n of x, which is equals to e raised to minus integral a1 of t dt, the integral from x0 to x, where x0 is the initial point, dt, into the Wronskian of phi 1 comma phi 2 comma phi 3 dot 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 phi n. Means see this, I shall explain this concept here. Suppose that, see here, 1 minute. Suppose if we consider interval I, now linear differential equation, see this system of a linear differential equation of order n with variable coefficient. Suppose if we consider the interval I, this is the suppose interval I, then x0 we have mentioned as an initial point. Suppose x0 is the initial point. Okay. And suppose x is another variable point, then we can write the Wronskian at the point x. That means the Wronskian of x by using the Wronskian of x naught. If you know the Wronskian of initial value, that is x naught, by using this we can write the Wronskian of x, that is formula for that is Wronskian of x, which is equals to e raised to minus integral from x0 to x a1 of t dt into Wronskian of x naught. This is our theorem statement which we have to prove. लेकिन यहाँ पे x naught and x must be on the given specified interval. यहाँ पे ये जरूरी है आपको x and x naught be both are on the specified in the specified interval I. Then we can write Wronskian of x by using the Wronskian of x naught. This is important. We have to prove this theorem. That means the relation between the Wronskian x and x naught, Wronskian x naught. But here x naught is a generally initial point. Initial point. Okay, now we shall start the proof. This is proof. We have to prove this result. Okay. Now, first of all, prove this result for the simple case n is equals to 2. Before going to prove the general value of n, first of all we have to prove this theorem for n is equals to 2. That means for Wronskian of phi1 comma phi2 of x, which is equals to e raised to minus x naught integral x naught to x of a1 of t dt into Wronskian of phi1 comma phi2 of x naught. That means we have to prove n is equals to 2 for and give the proof which is valid for general. We have to convert this into the general value of n. Later the proof makes use for the general properties of the determinant. Now we have to use this theorem for the general properties of the determinant. Now proof for n is equals to 2. In this case we know that. Now अभी क्या prove करना है रे आपको students? Actually we have to prove, see this, actually we have to prove Wronskian of phi1 comma phi2 of x, which is equals to e raised to minus x naught to x a1 of t dt into Wronskian of phi1 comma phi2 of x naught. Means we have to prove for the case n is equals to 2. Now see this, Wronskian of phi1 comma phi2, you know that. What is the definition of the Wronskian of phi1 comma phi2? Wronskian of phi1 comma phi2, which is equals to phi1 phi2 phi1 dash phi2 dash. Now you know that determinant is the cross product, so we get the result as phi1 phi2 dash minus phi1 dash phi2. So we get the result in this way. Say this. So we can write this. Now Wronskian dash, again if we differentiate this, then by using the product rule, the derivative of this term is this. By using the product rule, derivative of this term is this. So we get the result is that this term and this term will be get cancelled. So both terms are remaining, phi1 phi2 double dash minus phi1 double dash phi2. This is the Wronskian of phi1 phi2, Wronskian dash, dash means the derivative of phi1 phi2. So here phi1 phi2 satisfies the second order homogeneous differential equation with variable coefficient. See this, a1 of x means variable coefficient. So phi 1, phi 2 satisfies the second order homogeneous differential equation, linear homogeneous differential equation having a variable coefficient. So we obtain phi 1 double dash is equals to minus a1 phi 1 dash minus a2 phi 1. So phi 2 double dash is equals to minus a1 phi 1 dash plus a2 phi 2. How we can write this? If we replace this phi 1 double dash, see this. So phi 1 double dash is equals to phi 1 dash phi 1. So transfer this on right side, then we get this. म्हणजे या सोल्यूशन मध्ये हे कसं मिळवलं पहा. हाऊ वी ऑब्टेन दिस? रिप्लेस phi 1 in place of y, which is the linearly independent solution. Phi 1 double dash is equals to a1 phi 1 dash minus घ्या, हे ट्रान्सफर होतो राइट साइडला, a1 phi 1 dash minus a2 phi 1. If we replace phi 2 double dash, then similarly a1 phi 2 dash minus a2 phi 1 dash. So we get Wronskian dash equals to, replace this value in place of phi 2 dash here, replace this in place of phi 2 dash. यहाँ पे देखो ये phi 2 dash में replace करो, ये phi 1 dash में replace करो. So we get the relation. Don't write with me, you can write this after the completion of the lecture. Slowly you can write. So phi 1, replace this phi 1 dash minus phi 2 dash, phi 1 into phi 2 dash. See this, 1 minute. Phi 1, ये देखो यहाँ पे phi 2 double dash है, phi 1 into phi 2 double dash. So we can write, this is a phi 1, replace this phi 2 double dash minus phi 1 double dash, replace this phi 1 double dash here into phi 2. So we get, after calculation, after multiplication, we get, after multiplication taking out a common a1, then we get minus a1 phi 1 into phi 2 dash minus phi 1 dash into phi 2. So actually this is the value of Wronskian of a phi 1 comma phi 2. See this, Wronskian of phi 1 comma phi 2 which we have taken here. See this, Wronskian of phi 1 comma phi 2 which we have taken here. So this gives the result as Wronskian dash phi 1 comma phi 2 is equals to minus a1 Wronskian of phi 1 comma phi 2. We know that phi 1 comma phi 2 satisfies the linear first order differential. So y dash plus a1 of xy which is equals to 0. So according to the solution of the first order linear differential equation, we know that the solution of the first order linear differential equation c into e raised to ax. So we can write Wronskian of phi 1 comma phi 2 of x is equals to c into e raised to minus x0 to integral x0 to x a1 of t dt. Actually you know that this we have seen in the in the class of B.Sc also. The first order solution of the linear differential equation of the first order we have expressed in the form of this, which is compared with the Wronskian. So Wronskian of phi 1 comma phi 2 of x can be written as c1 e raised to x naught to x a1 of t dt, where c is a constant. By putting x is equals to x naught, we can obtain the value of c. अगर हम x is equals to x naught पुट करते हैं तो c की वैल्यू होती है c is equals to Wronskian of, because अगर x is equals to x naught होता है तो integral from x naught to x naught means which gives a 0. So the value of e raised to 0 means 1. So left side becomes only c. So that is a c. Right side becomes only c. and left side becomes Wronskian of phi 1 comma phi 2 of x naught, because we have to put x as a x naught. So C will be x into x naught. So we get the relation. मग कसं relation मिळेल? So this, thus we can prove the n is equals to 2. How we get this n is equals to 2? See this, we have proved this. N is equals to 2 means, so Wronskian of phi 1 comma phi 2 of x, which is equals to, ये देखो यहाँ पे पुट अप करना है, फिर से यहाँ पे पुट अप करना है. We have to put, see this, see, Wronskian of phi 1 comma phi 2 x, which is equals to, C means Wronskian of phi 1 comma phi 2 of x naught, and this exponential term as it is e raised to minus integral from x naught to x a1 of t dt into Wronskian of phi 1 comma phi 2 of x. We have proved this relation. In first case, we have proved the result is true. See this. This result is true for n is equals to 2. n is equals to 230, we have proved this result. अभी देखो, next we have to generalize this up to the n. We have to generalize this up to the n. हा theorem important theorem आहे पहा. Now proof for general n. Let W, suppose W is considered as a Wronskian of phi 1, phi 2, phi 3 dot 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 phi n. For the variety, from the definition of W as a determinant, it follows that its derivative W dash is a sum of n determinants. Suppose its derivative W dash is supposed to be sum of n determinants. Okay. Now see this, W is equals to Wronskian of phi 1, phi 2, phi 3, phi n, and W dash is the derivative which is equals to the sum of n determinants. Suppose that determinants are, see this, V1, V2, V3 dot dot Vn, where Vk differs from W only its kth row and kth row of Vk obtained by the differentiating kth row of W. ओके, म्हणजे प्रत्येकाचा रो डिफरन्शिएट करून आपण kth means V1, V2, V3, we can generalize this. See this in this way. W is equals to, suppose W dash means the derivative of Wronskian, which is the sum of nth determinant, generally which is denoted by Vk by taking the derivative of kth row. See here, suppose this is a V1 means derivative of first row of the Wronskian. See this, you know that. मैं यहाँ पे मैं इसको एक बार फिर से आपको explain करता हूँ, 1 minute. You know that what is the Wronskian? You know that what is the Wronskian? Wronskian means determinant of phi 1, phi 2 dot 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 phi n. Second row, phi 1 dash, phi 2 dash dot 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 phi n dash. Third row, in this way, dot 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 phi, suppose phi 1 raised to n minus 1, phi 2 raised to n minus 2 dot 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 phi n raised to n minus 1. Suppose this is a Wronskian. Now its derivative is a sum of determinants V1, V2, V3 dot 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 Vn. We consider that as a suppose Vk. Vk means general term, general determinant, any determinant Vk, such that its kth derivative of its kth row. अभी देखो ये V1 है, सी दिस इज द फर्स्ट V1. अभी ये कैसा लिया मैं आपको बताता हूँ. सपोज दिस इज a V1, so we take this V1. V1 means the determinant which is obtained from Wronskian by taking derivative of first row. 1 means first row, so we have taken here the derivative of first row. See this, derivative of first row. Now this is a V2. V2 means here we have given Vk is obtained by taking derivative of kth row. So V2 is obtained by taking derivative of second row. What is the actually second row? See this here, the second row is phi 1 dash, phi 2 dash, phi 3 dash, dot 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 phi n dash. So V2 can be obtained by taking the second derivative phi 1 double dash, phi 2 double dash, dot 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 phi n double dash. Similarly, we can obtain V3. How we can obtain V3? So this is a phi 1, phi 2 dot dot phi n. Second as it is phi 1 dash, phi 2 dash, dot 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 phi 3 phi n dash. Now V3 means the determinant obtaining derivative of third row. Actually, which is the derivative of third row? Phi 1 double dash, phi 2 double dash. So we can write here phi 1 triple dash. Third row becomes phi 1 triple dash, phi 2 triple dash, dot 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 phi n triple dash. Fourth row same and remaining are as it is. Only we have to take the third derivative of third row. Means here V1 means derivative obtained by first row from the Wronskian. V2 means derivative obtained by the second row from the Wronskian. V3 means derivative obtained by the third row from the Wronskian, dot dot dot. In this way we can write in general. Suppose Vn, now see this is a Vn. This is a Vn. Vn means derivative obtained by nth row. Actually this is a nth row, because this is a zero order derivative, because there are n row and n columns. You know that Wronskian phi 1 comma phi 2 dot 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 phi n of x, which is the determinant of order n. It has n row, n columns. Therefore the last row is, see this, nth row. This row is nth row. So Vn can be obtained by its nth row's derivative. So n minus 1 चा, see this, अभी देखो यहाँ पे n minus 1 का डेरिवेटिव होता है phi 1 raised to n minus 1 का अगेन डेरिवेटिव लेने के बाद n होता है n minus 1 plus 1 means n. So phi 1, यहाँ पे 1 लिखना है, phi 1 raised to n, phi 2 raised to n, dot 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 phi n raised to n. Students, do you understand this? How we get the phi 1 w dash? How we get the w dash? Do you understand this concept? Okay. Now see this. Next, the first n minus 1 determinants V1. V1, okay, no problem. V1 काय म्हणतात? V1, V2, V3 dot 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 V1. ओके. V1 म्हणजेच Wronskian मधील फर्स्ट रोचा डेरिव्हेटिव्ह घ्यायचा, Wronskianचा. W डॅश काढत असताना V1 म्हणजे Wronskian मधील फर्स्ट रोचा डेरिव्हेटिव्ह घ्या. V2 म्हणजे Wronskian मधील सेकंड रोचा डेरिव्हेटिव्ह घ्या. V3 मीन्स Wronskian मधील थर्ड रोचा डेरिव्हेटिव्ह घ्या. बाकीचे सर्व ॲज इट इज, बाकी काही चेंज करायचं नाही Wronskianच्या टर्म. डॉट 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 Vn. ओके. So the first n minus 1 determinants of V1 comma V3 dot dot Vn are all zeros, since they each have two identical rows, since phi 1 comma phi 2 comma phi 3 dot 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 are the solutions of L of y is equals to 0. So we can write phi I raised to here. अभी देखो यहाँ पे क्या होता है, ये जो डिटर्मिनेंट्स है, ये देखो ये डिटर्मिनेंट्स है, इसमें देखो यहाँ पे ये दो रो सेम है. According to the property of determinant, if any two rows or any two columns are identical, then the value of that determinant is 0. So value of this determinant 0, the value of that determinant is 0, value of third determinant is also 0, but in the last determinant here, there is no any two rows are identical. यहाँ पे देखो ये अलग रो है, इसके पहले वाला n-1 का है, यहाँ पे सेम रोज नहीं होते, सो इट इज नॉट इक्वल्स टू 0. दिस इज नॉट इक्वल्स टू 0. सो वी कैन राइट the first n-1 determinants, that is v1, v2, v3 dot dot vn minus r are all zeros since they have two identical rows. Therefore, since phi 1, phi 2, phi 3 are the solution of L of y is equals to 0, therefore we have, according to अतः phi I raised to n, phi I raised to n, देखो ये solution है nth order linearly homogeneous differential equation का अगर phi 1, phi 2, phi 3 solution है, then we can write phi I raised to n here. Phi I raised to n, which is equals to minus a1 phi 1 raised to n minus 1 minus a2 phi raised to n minus 2 dot 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 an phi 1, which is equals for I is equals to n. This is obtained as like from this. ये देखो ये कैसा हमने लिया था, ये सेकंड ऑर्डर डिफरेंशियल इक्वेशन का. अगर phi 1 phi 2 सॉल्यूशन होता है सेकंड ऑर्डर डिफरेंशियल इक्वेशन का, तो phi 1 dash can be written in the form of a decreasing order of the derivatives. Phi 1 double dash can be written as the form of a decreasing order. Same process we have to write for the nth order derivative, nth order differential equation. We can write phi I raised to n can be written as a1 phi I raised to n minus 1 minus a2 phi raised to n minus 2 dot 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 an phi I, because phi 1, phi 2, phi 3 are the solutions of linearly independent. Therefore, we get the Wronskian dash. So, according to this equation, we can write phi 1 Wronskian dash is equals to phi 1, phi 2 dot 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 phi 1 dash dot 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 phi 1 raised to n minus 2 dot 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 in this way, and this minus j raised to summation minus aj. In general, we have represented this. Okay. So, the value of determinant is unchanged if we multiply any row or any row by number and adding the last row. Determinant ची property है. According to this property of the determinant, we can say that now we multiply the first row by an and second row by an minus 1. Continuing this process, we get the first row by an minus 1 by a2, add all these values in the last row. म्हणजे प्रत्येक रोला अभी आपको यहाँ सेकंड रो को an से मल्टीप्लाई करना है, फर्स्ट रो को an से, सेकंड रो को an माइनस 1 से, थर्ड रो को इन दिस वे, लास्ट रो को या n माइनस 1 से मल्टीप्लाई करना है ये 2 को, एंड वी हैव टू add all these in the last row. So we get the equation, the final equation, that is minus a1 into Wronskian. हे प्रोसेस तुम्ही थोडं लक्षात घ्या, हे डायरेक्ट घेतलेले आहे प्रोसेस. Therefore W satisfies the linear first order differential equation y dash a1 of xy, which is equals to 0, and thus we can prove Wronskian of x is equals to e raised to minus integral from x naught to x a1 of t dt which is equals to Wronskian of x naught, and hence we can prove this result. ओके, म्हणजे अशा पद्धतीनं हे आपलं इथं प्रूव्ह होतं आणि ही कंडिशन ट्रू होते. इथं A1 कॉमन काढलेला आहे, लक्षात घ्या. दिस इज A1 मायनस A1 कॉमन काढला हा टोटल. इफ वी टेक द कॉमन मायनस A1 हिअर, if we take the minus A1 common here, then we get the remaining determinant as a Wronskian. So W dash, we get W dash is equals to minus A1 into W. To remove this, अशा पद्धतीने हे complete solution होतं. Okay, and hence we can prove this theorem. Okay, अशा पद्धतीने हा theorem prove होतो. तुम्ही 2-3 वेळा व्यवस्थित you can write this theorem. You can write this theorem 2 or more times, then you will get it easily, because this is a very important theorem series. हा खूप important theorem आहे, त्यामुळे हा theorem चांगल्या पद्धतीने सॉल्व करा, होऊन जातो, काही अडचण नाही. फर्स्ट यू हॅव टू अंडरस्टँड द केस n is equals to 2 and then result. This is important theorem. Actually this is a very important theorem for 15 marks. Okay, now we shall stop here. नमस्कार, गुड बाय. हा, या थेरमवर काय म्हणते क्वेश्चन, 1 मिनिट. या थेरमवर MCQ. हा, ओके, या थेरमवर MCQ कसा विचारला जातो. सी दिस, इफ phi1 phi2 phi3 dot 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 phi n are the solutions of L of y is equals to 0 in on an interval I and x naught be the solution of this, then which of the following is true? So we have to given different options regarding this. Suppose this is a first option A, suppose this is a second option, Wronskian of phi1 comma phi2 dot 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 phi n of x naught is equals to same this, which is equals to Wronskian of phi1 phi2 dot 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 phi n of x naught. For x naught, ikkada x1 x2, whatever may be, you have to given this condition e raised to x. You can change this condition e raised to x, means these are the different options. We have to express this option in the different ways. Okay, हाँ बोलो, मुझे अभी ऐड करो सर ग्रुप में. ओके, नो प्रॉब्लेम. आणि सर्वांना सूचना आहे, प्रत्येकाने टेस्ट देणं गरजेचं आहे. तुम्हाला टेस्ट ही तुमच्या खूप महत्त्वाची आहे. टेस्ट प्रत्येकाने देणं गरजेचं आहे. आपली जी इंटरनल टेस्ट होणार आहे सुरुवात, त्या टेस्टला 22 तारखेपासून जी इंटरनल सुरुवात होणार आहे ते प्रत्येकाने देणं गरजेचं आहे. नाउ वी शॅल स्टॉप हिअर. गुड बाय.